Hello everyone. In this session of CCNA series, I'll discuss about IP address classes. There are around 4.3 billion IPv4 addresses. Managing all those addresses without any scheme are next to impossible. Let's understand it with a simple example. If you have to find a word from a language dictionary, how long will you take? Usually you will take less than 5 minutes to find out that word. You are able to do this because words in the dictionary are organized in alphabetic order. If you have to find out the same word from the dictionary which does not use any sequence or order to organize the words, how long will you take this time? It may take up to 1 week to find out what that specific word from all the words. If an unorganized dictionary which roughly contains 1 billion words can take a 5 minutes task in a 1 week task, then suppose how nearly 4.3 billion addresses will make a search task complicated if they are unorganized. For easier management and assignment, IP addresses are organized in numeric order and divided in following 5 classes: Class A, Class B, Class C, Class D, and Class E. Each class has a range of valid IP addresses. The value of the first octet determines the class. For example, 0 to 127 determine the Class A IP address range. 128 to 191 determines the Class B IP address range. 192 to 223 determines the Class C IP address range. 224 to 239 determines the Class D IP address range. And the last 240 to 255 determines the Class E address range. IP addresses from the first 3 classes, A, B, and C, can be used for the host addresses. The other 2 classes are used for other purposes. Class D for multicast and Class E for experimental purposes. Let's see how the classes were created. As you know, an IP address is the combination of network and host ID. In each IP address, few bits are reserved for network address. The classes were created based on the network size. In Class A, the first 8 bits are reserved respectively for network addresses, which gives you the subnet mask of /8 or 255.0.0.0. In Class B, the first 16 bits are reserved respectively for network addresses, which gives you the subnet mask of /16 or 255.255.0.0. In Class C, the first 24 bits are reserved respectively for network addresses, which gives you the subnet mask of /24 or 255.255.255.0. For example, for the small number of networks with a large number of hosts, the Class A was created. The Class C was created for numerous networks with small number of hosts. Let's use an example to find the class of 3 different IP addresses: 1.2.3.4, 191.200.100.1, 192.168.1.1. To find the class of an IP address, simply pay attention on the first octet. Let's start with 1.2.3.4. If the value of the first octet is in the range of 1 to 127, you can say it's a Class A IP address. If the value of the first octet is in the range of 128 to 191, it's a Class B IP address. If the value of the first octet is in the range of 192 to 223, it's a Class C IP address. That's it for this